Calculus BC, lesson 5.5, finishing up example 4, our last video left off right before we could finish this up. If you look up at the right side of the screen here, we've got 9 to the 3 halves. That half power really indicates we're going to take the square root of 9 and then cube that. So that's 3 to the 3rd power, that's going to be 27. And of course, 1 to any power is going to just be a 1 itself. So 27 minus 1 is 26. We'll just have 26 over 3. So what we're seeing is that when you have a definite integral, when you have specific bounds, I should say, you can make your u substitution, but change your bounds. And then you can keep everything in terms of u. You can finish your problem. And not have to resubstitute back. And let's take a look at 2 more problems. For example, 5, again, maybe first go in search of a composition, a function inside of another function. It sure looks like we have 3 minus 5x that is inside of that squared function down below. And we can quickly make note of that and take derivatives. Keep in mind we also have boundaries in this. We do have a definite integral here, so another bit of practice that we can have. So du, if I take the derivative on the left, well, the derivative of 3 is 0. Derivative of negative 5x is negative 5, and then we have dx. But dx, of course, is really going to be du all over negative 5 when we divide both sides by that. So we're getting close. We can see right here that we're going to make a couple of substitutions, but we're also going to have to change our boundaries. As we're looking here, this problem, the dx, is telling us that our lower bound is x equals 1, our upper bound is x equals 2. If x equals 2, well, look in green right here. If x is equal to 2, 5 times 2 is 10, and 3 minus 10, well, 3 minus 10 is going to be negative 7, isn't it? So it would only take a moment to get that. Now, if x is equal to 1 for our lower boundary, then u would equal negative 2. So what can immediately seem to be a little troubling is that I do have new boundaries, but the smaller number, clearly negative 7, is smaller than negative 2. Looks like our smaller number is up on top. Down below, I'm going to have u squared. This dx, I'm going to move over to the side, and then I can quickly see that we have a du all over negative 5. Well, as we try to clean this up, tell you what, I'm going to factor out a negative 1/5, and we can go from negative 2 to negative 7. While we're at it, I think I'll write this as u to the negative 2. And undoubtedly, I'm sure some kids are a bit uneasy seeing what we saw before with our boundaries, with that smaller number up on top. Mind you, you don't have to make this change, but I do want to point out that you can. I'm going to change this negative 1/5 to a positive 1/5 and then flip the order. Remember, that was a property of integrals that we certainly can always make use of. When you change the boundaries, a negative comes out in front. So you can envision that I flipped it, another negative came out, and a negative times a negative is a positive. Well, at this point, let's do our fundamental theorem. Bump our power up by 1, you'd get u to the negative 1. But then, of course, we have to divide by our negative 1 as well. And let's just do a little more cleaning up while we're at it. This negative right here becomes a negative 1/5. And then I could say I've got 1 over u, and of course I'm going to plug in a negative 2 and a negative 7. So the fundamental theorem really is saying that first we'll say 1 over negative 2, and then we'll say minus 1 all over negative 7. At this point, well, I hope you can see minus a negative turns to plus a positive. So that's all well and good. Let's see where we're going next. If we were to get a common denominator of 14, this negative 1/2, if I multiplied by 7 over 7, I'd wind up with negative 7 over 14. Multiply by 2 over 2 here, and we'd get 2 over 14. So we'd get negative 5 over 14. And then, of course, out in front, we'd have a negative 1/5. Now, a negative times a negative is a positive, and our 5s could cancel, and we'd be left with a single answer of 1/14. Please understand, and this is super important too, that it's okay if our answer would have been negative. Remember, integrals really represent net area underneath the curve. So sometimes your integrals are positive values, sometimes they're negatives. Every once in a while, a kid gets nervous if something works out to be a negative. Well, here's our last problem, and we definitely have to talk about this one. It will show up eventually, and it's this type of problem where I think even kids who begin to feel like they're really doing well with U substitutions, they might get to this particular problem and feel very uneasy. Well, I see a 1 plus x squared inside of the square root, and my guess is I'll let u equal that expression. By the way, that's good thinking. That is, in fact, where we're going. By the way, we're back to an indefinite integral, no boundaries. Actually shortens the process a little bit. So then we'll have du is equal to 2x dx, and then dx will equal du all over a 2x. So it's usually at this point where kids are feeling very confident and they're feeling good, but perhaps in just a moment, that feeling confident and good begins to lead to a sense of panic. Here's what we're getting at. You can come up with this integral. You'd have the square root of this expression. Well, that's the square root of u. And then all of a sudden your dx becomes du all over 2x. And here's where kids get upset, and I think you can see why they're getting upset. They'll say, wait a minute, things aren't canceling. See, look at this. Yeah, we've got a 1 over 2, and I could factor out a 1/2. That's all well and good. That's not the issue. This x would cancel with x to the 5th, leaving you with x to the 4th. If you're left with x to the 4th, here's the problem. You now no longer have an integral exclusively in terms of u. So it appears that we're in a good world of trouble. You can think, how in the world can we ever get out of this? And here's how. Go back to this u substitution. But I want you to pay attention to this statement. I could solve for x squared. And if I square both sides, I'm going to have an expression for x to the 4th. That's the key. So at first glance, we might get very, very, very upset. But now if we went back and if we'd say, wow, things aren't canceling, things just aren't working out, you could go back to where you had substituted, see if you might be able to gain a little bit more help. We do. Look at this. This square root of u, I'm going to write as u to the 1/2. And over here we'll have u minus 1 quantity squared du. Now I think it's at this point, I hope, where with some algebra you'd be able to finish this off. Let's see where we're going. If I'm squaring this thing, guys, it's u squared minus 2u plus a 1. And then I'm going to distribute. Look, we do have to do some algebra. This problem, they're really making us work for this antiderivative. but it's about to get better. 1/2 plus 2, well, that's 1/2 plus 4 over 2, that's 5 over 2. 1/2 plus 1, well, that's 1/2 plus 2 over 2. This becomes u to the 3/2. And here finally you get u to the 1/2. Wow, at this point, thankfully, we can take our antiderivative. We can say, well, bump this up, we'd get u to the 7/2. Add 2 over 2 to it, but then you're going to have to multiply by its reciprocal. Dividing by 7/2 is multiplying by 2/7. Bump this up to a 5/2. But then what? We're really going to be multiplying by the reciprocal, 2/5. Likewise, over here, you add a 1 to 1/2, you'll get 3/2, but then multiply by 2/3. And then we'll have our little constant. You know, I'm going to distribute a 1/2 in here too. Here, the 1/2 kills the 2. We'd have 1/7 u to the 7/2. One of these 2's is going to be canceled. You can think of it that way. You'd be left with a minus 2/5 u to the 5/2. The half distributing here would kill this 2, so we'd have 1/3 u to the 3/2 plus a constant. But here's where it's so tricky. You can say, well, here's my final answer. Guys, honestly, you got to remember u was 1 plus x squared, wasn't it? If you leave this as your answer, that's not in terms of x. So this answer looks brutally ugly. But this is just the way we're going to have our answer. You've just found a very tricky integral. This is definitely a problem that took a lot of work, but hope that this is making sense. If you ever get to a point where it seems like things aren't canceling out, go back to your u substitution. You might just find a pleasant surprise where you can solve for your x or x to a power and make it work.